It is 11:37 a.m. local time, somewhere over international waters in the southern Caribbean. The sun hangs above the horizon like a white-hot furnace, scattering blinding reflections across the turquoise sea. But inside the cockpit of a Venezuelan Air Force F-16A, Captain Javier "Viper" Ramos feels anything but warm. His right hand grips the flight stick, damp with sweat. His eyes stay locked on the radar screen where a signal flickers just 30 nautical miles ahead. To the naked eye, it is only a small gray shape against the endless blue. But Ramos knows exactly what it is. The USS Jason Dunham, a United States Navy Arleigh Burke-class destroyer. His orders are clear. Close the distance, demonstrate air superiority, and pressure the American vessel into changing course. This is not a training flight. This is a tense, high-stakes contest of nerve, speed, and technology. Condor, maintain flank position. 2-mile separation. "I'll take the high-speed pass," Ramos says over the radio, his voice controlled even as adrenaline rushes through him. He pushes the throttle forward. The F-16's Pratt and Whitney F-100 engine surges, driving the jet from 450 knots to more than 600. The aircraft begins to tremble around him, the vibration rattling through his helmet and against the canopy. He is flying a Cold War-era fighter toward one of the most advanced naval vessels on the planet. And for one brief, dangerous moment, Captain Ramos feels the addictive rush of being in control. His AN/APG-66 radar, an old pulse Doppler system with roots in the 1970s, gives him a steady lock tone. The massive ship is centered on his scope. He selects his primary air-to-air system, an AIM-9 Sidewinder, guided by an infrared seeker designed to follow heat. The distance closes fast. He is approaching the invisible boundary where his show of force will either work or completely fall apart. It is the unseen perimeter shaped by the ship's defensive network, a zone where confidence can disappear in seconds. Ramos focuses on the target ahead, unaware that the American vessel has been tracking his every movement since the moment he rolled out of the hangar 200 miles away. He is about to learn a harsh lesson. When older analog-era technology challenges a modern digital combat system, the result is rarely balanced. The next 60 seconds will become a masterclass in technological humiliation. And the most dramatic moment will not come from an impact. It will come from an entire system going silent. The USS Jason Dunham, hull number DDG-109, had been operating in the Caribbean as part of a routine maritime security and freedom of navigation mission. Its presence was meant to reinforce a simple principle of international law. Open waters do not belong to any single nation. This encounter was not a coincidence. Officials in Caracas, watching the American vessel move near an area they claimed as part of their exclusive economic zone, decided to force a confrontation. The goal was simple. If Venezuelan F-16S could push the destroyer into changing its course, it would become a major propaganda victory for President Maduro and support his government's aggressive maritime claims. For the U.S. Navy, the issue was far bigger than one ship's route. It was about protecting freedom of navigation and preserving the rules that keep global waters open. Inside the Combat Information Center of the Dunham, Lieutenant Commander Iler Vance, the tactical action officer, watches the situation unfold with disciplined calm. The Combat Information Center is a hidden world beneath the decks, washed in blue light and glowing green displays. It is the tactical nerve center of the entire ship, the place where every sensor, signal, and decision comes together in real time. On several screens, the two fast-moving inbound aircraft are already being tracked. Their profiles are identified almost instantly as Venezuelan Air Force F-16A fighters. For the crew, the designations are simple: Viper and Condor. Lieutenant Commander Vance understands the move before the pilots even commit to it. Not because of guesswork, but because the destroyer is connected to a much larger intelligence network. Satellites, airborne sensors, maritime patrol assets, and regional monitoring stations have already helped build the picture long before the aircraft appear close enough to matter. This is not shaping up like a traditional confrontation. It feels more like a live systems check, a real-world test of how the Aegis platform responds when older generation aircraft attempt to challenge a modern naval defense network. The political line is extremely thin. The goal is to discourage escalation without opening the door to anything more serious. The message must be clear. The ship does not need to change course, and it does not need to react emotionally. Its digital shield is already speaking for it. Captain Ramos, however, believes he still has the advantage. From his cockpit, speed feels like power. Surprise feels like control. His aircraft is fast, maneuverable, and respected within Venezuela's Air Force. The F-16A Block 15 remains one of the country's most capable fighter platforms, acquired during the Cold War and still treated as a symbol of national strength. In isolation, the aircraft is impressive. But in this environment, its limitations matter more than its strengths. Its AN/APG-66 radar can detect a large vessel at roughly 80 nautical miles under favorable conditions. But it struggles with resolution and can have difficulty separating useful returns from sea clutter. Its radar warning receiver, the AN/ALR-69, belongs to an earlier generation. Against a modern electronic warfare suite, it can be confused, saturated, or presented with a picture that does not fully reflect what is happening around it. For the pilots, the pressure is both political and personal. They are flying with national pride, but also under strict expectations from above. Their task is to appear confident, press close, and create the impression that the American ship is being forced to respond. Their approach is a classic aggressive display. Come in fast, stay low, reduce detection time, then make a sharp turn to gain visual position and simulate a launch profile. Ramos has been trained to believe that a warship, when challenged in this way, will alter course or show visible defensive movement. Even a slight course change could be used as a symbolic victory. But Ramos does not fully understand the environment he is entering. His aircraft was built for the air combat logic of the late Cold War. The ship ahead of him belongs to a different century. It does not need to panic, turn away, or make a dramatic move. The USS Jason Dunham is not just a vessel on the water, it is a floating networked fortress, designed to see, classify, process, and respond faster than the human eye can follow. To the American crew, the Venezuelan fighters are not simply approaching aircraft, they are sources of valuable data. Every radar pulse, every radio transmission, every adjustment in altitude and speed helps the ship's systems build a more complete electronic fingerprint. What Ramos believes is a show of strength may actually be giving the Dunham exactly what it wants. A detailed look at how these older aircraft behave under pressure. The defensive preparation aboard the USS Jason Dunham represents a generational leap in technology. At the heart of it is the Aegis Combat System, a modern baseline 9 configuration running on high-speed commercial, off-the-shelf processors. It links sensors, command systems, and response options into one integrated picture, allowing the crew to track the airspace with extraordinary precision. The brain of this entire system is the SPY-1D-V multifunction radar, a powerful passive electronically scanned array. Unlike the F-16's older rotating radar, which can focus in only one direction at a time, the 4 fixed faces of the SPY-1D-V watch every direction at once. It can follow hundreds of objects simultaneously at ranges beyond 250 nautical miles, creating a constantly refreshed picture of the battle space in milliseconds. This is not just a radar. It is part of a larger digital shield, a network where every sensor, processor, and defensive option works together as one system. But the ship's quietest advantage is its AN/SLQ-32V 6 Surface Electronic Warfare Improvement Program, known as SE-WIP Block 2. This advanced electronic warfare suite does far more than alert the crew to incoming radar activity. It can study a signal, understand its pattern, and answer it with a carefully shaped electronic response. When the F-16's radar begins tracking the ship, the SLQ-32 immediately analyzes the frequency, pulse pattern, and waveform. Then it creates a custom countermeasure designed either to overwhelm the signal or send back misleading targeting information. To the pilot, the picture inside the cockpit can suddenly become unreliable, even when the aircraft itself still feels perfectly under control. For layered defense, the Jason Dunham carries a full suite of response systems inside its 96-cell Mark 41 vertical launch system. It includes SM-2 interceptors for long-range protection and evolved Sea Sparrow systems for threats that move closer. The SM-2 is built for distance and speed. The Sea Sparrow is designed for sharp, last-second maneuvering, capable of extreme turns in the final phase of its approach. Closer still is the Phalanx Close-In Defense System, a fully automated last-layer safeguard designed to react only if something enters its tightly defined protective envelope. Every layer exists for one purpose, to make sure the ship has options at every distance. From the moment the SPY-1D-V detects the approaching F-16S at long range, the Aegis system classifies them, predicts their path, and prepares a response sequence in less than 5 seconds. Everything is ready. The only thing missing is the final human decision from Lieutenant Commander Vance. The clock moves toward 11:38 a.m. Captain Ramos, holding Mach 0.9, crosses into the 25-mile zone. On the displays inside the Jason Dunham's Combat Information Center, his aircraft is no longer a distant marker. It is a clear, unmistakable track. Lieutenant Commander Vance makes the first move. TAO to EW. Execute Countermeasure Program Guardian 7 Sierra. Passive, non-kinetic engagement. The order activates SEWIP Block 2. Inside Captain Ramos's cockpit, his old AN/ALR-69 radar warning receiver suddenly loses its calm. The steady lock tone from his AN/APG-66 radar, the signal that made him believe the destroyer was centered and under control, breaks apart into a storm of alerts. Lights flash across the panel. Warning tones overlap. His display now suggests he is being illuminated by 7 powerful American radar sources from 7 different directions. That should be impossible. Then his own radar screen washes out into static. The SEWIP system has generated a precisely matched electronic noise pattern, strong enough to bury the return he was relying on. One moment, the destroyer is fixed on his scope. The next, the largest object in front of him seems to vanish into a wall of digital snow. Ramos is stunned for a split second, but years of training take over. He immediately switches his AN/APG-66 radar into home on jam mode, an older fallback technique that allows the aircraft to follow the source of interference. But that decision only deepens the trap. He thinks he is adapting. In reality, he is now flying exactly along the path the American system has prepared for him. At 11:39 a.m., the F-16S close to 15 nautical miles. The electronic interference has pushed them lower, forcing both pilots to depend more on instinct than instruments. CIC to bridge, all stations. Warning signal only. Release 1 chaff bundle, starboard quarter. A small canister opens near the ship, scattering a bright cloud of aluminum-coated fibers into the air. It is not an attack. It is a message. A visible, unmistakable reminder that the destroyer sees them clearly, understands their next move, and has already answered it. At the same time, the Phalanx close-in defense system at the stern begins its internal sequence. The 6 barrels of the 20mm M61A1 Vulcan cannon start to rotate with a low mechanical whine. It is not used. It does not need to be. The sound alone is enough to carry a message, and it will be captured by the approaching aircraft's cockpit recorders. Lieutenant Miguel Condor Soto, Ramos's wingman, breaks radio silence. His voice is tight. Viper, I have no lock. Repeat, my radar is completely blind. I'm showing multiple emitters. By 11:41 a.m., Ramos is close enough to see the destroyer with his own eyes, just 5 nautical miles ahead. Desperate to salvage the mission, he pulls the F-16 into a hard 4G turn, trying to line up an infrared shot with his AIM-9P system. He needs the seeker to detect a clean heat source from the ship. He tries to guide the Sidewinder's seeker head onto the target. Nothing. The AIM-9P belongs to an earlier generation. It needs a sharp, distinct heat signature to track. The Jason Dunham is large, but its exhaust is shielded, its heat is dispersed, and against the bright Caribbean water, it presents only a cool gray outline. The U.S. Navy has spent decades reducing visible and infrared signatures, and now that design work is paying off. Ramos understands the problem instantly. His best available system cannot get a clean lock on a vessel built for a different era of warfare. The Aegis network has already won the encounter without using a single interceptor. At 11:42 a.m., Captain Ramos reaches the point where pride can no longer overcome reality. His radar is unreliable, his infrared system is silent, his wingman is blind. And somewhere below, that steady mechanical hum from the ship's close-in defense system seems to vibrate through the air itself. His mission was to pressure the American destroyer into changing course. Instead, he has been outmatched without the ship ever needing to turn. He is an analog pilot trapped inside a digital battlefield, defeated not by impact, but by information. Condor, abort! Break contact. Climb to 20,000 feet. Full afterburner. Heading 270. Ramos pulls away in a steep, fuel-burning climb. Moments later, the 2 Venezuelan fighters shrink into distant tracks on the SPY-1D displays. The confrontation is over. Inside the USS Jason Dunham's Combat Information Center, the atmosphere remains calm, almost silent. No one celebrates. No one raises their voice. The crew simply returns to procedure. Lieutenant Commander Vance slowly exhales. Her hand, which had been resting close to the fire control release for an SM-2 response, relaxes. EW, cease countermeasures. Resume normal monitoring. TAO to bridge. Maintain course and speed. Generate report. The total cost of the defensive response was almost nothing. 1 small chaff bundle and a modest amount of power used by the SEWIP suite. Meanwhile, the 2 Venezuelan F-16S burned through thousands of pounds of fuel in a failed intimidation maneuver, exposing their limits, their vulnerabilities, and the weaknesses of their electronic systems. But the true prize was not tactical. It was intelligence. Every millisecond of the encounter had been recorded. The AN/SL Q-32 system was not only interfering with the F-16 sensors, it was studying them. It captured the exact electromagnetic signature of the Venezuelan AN/AP-G66 radar and mapped the communication patterns used by the pilots. By the time the fighters turned away, the U.S. Navy had gained a clearer picture of the Venezuelan Air Force than any briefing could provide. For Ramos and his wingman, the experience was crushing. They had arrived expecting to pressure a destroyer into changing course. Instead, they were outmatched by software, signal processing, and an invisible wall of electronic control. On board the USS Jason Dunham, there was no loud celebration, no dramatic reaction, just calm, professional satisfaction. The ship had not only protected its course, it had turned the entire situation into a training moment and an intelligence advantage. The lesson was simple. Modern naval power is no longer just about speed, size, or firepower. It is about information. The side that sees first, understands first, and responds first controls the situation before the other side even realizes what is happening. The Venezuelan F-16s were operating like isolated machines from another era, with pilots depending on limited information, older sensors, and split-second judgment inside a rapidly changing environment. The USS Jason Dunham was something completely different. It was not just one ship moving through the Caribbean. It was a connected node inside a much larger global network. Its Aegis combat system, paired with the SPY-1D radar, could process enormous amounts of data in real time. Its electronic warfare suite did more than disrupt the opposing aircraft. It learned from them, adapted to them, and turned their own signals into useful intelligence. That is what made the encounter so one-sided. Every part of the American system was connected. The sensors watching the aircraft before takeoff, the radar tracking them across the water, the command systems calculating options, and the defensive layers waiting silently in reserve. It was not a single platform against two jets. It was a full digital network against two aircraft built for a different kind of battlefield. When the Venezuelan pilots tried to challenge that network, they did not expose weakness. They revealed its strength. In the end, the American destroyer did not need to launch anything to prove its point. The technological gap had already decided the outcome. What was meant to be a bold display of pressure became a recorded lesson in the limits of outdated systems against modern naval defense. The sea lanes remained open, the ship stayed on course, the mission continued. And the message was unmistakable. In the modern era, control belongs to the side that combines technology, discipline, and information faster than anyone else. The real question is what happens when an opponent sees the warning and chooses to ignore it anyway. Which platform do you think has done more to prevent escalation in the Caribbean? The Arleigh Burke-class destroyer or the P-8 Poseidon surveillance aircraft? Share your thoughts in the comments. Ciao.